Hello, this is Bunton again with lesson 5 of our visual functional maths for entry level. Today we're going to deal with decimals and fractions. We're going deeper now into maths, and very soon you'll begin to appreciate the effort you're making to attend this lesson. So what are decimals? You will understand that decimals are units less than a whole or less than 1. You will add, subtract, multiply and divide in decimals. You will understand that fractions are parts of a whole. You will add, subtract, multiply and divide fractions. You will find fractions of a whole, and you'll convert fractions to decimals. You have learnt numbers. You know what numbers is. Now we're extending it from whole numbers to decimals and to fractions. This lesson has keywords which you need to understand. Whole, fraction, which is part of, decimal, which also is part of, and then equivalent. Equivalent is very important because, as I've already started teaching you, you need to be able to check your answers for correctness. So what are decimals? Not all numbers are whole numbers. Decimals are numbers with a decimal point in them. For example, you have 0.5, you have 1.3, you have 4.656, and so on. If you're saying the number out loud, you say point where the dot, the decimal point, should be. For example, you see 1, you see dot 3 is referred to as 1.3. Decimal points is used to show the numbers in between whole numbers. I would say the values in between 1 and 0. The digits to the right of the dot are worth less than 1. Now I'll go through this. It's important that we understand them. It's only 8 points, but they're very important. Not all numbers are whole numbers, as I've said. From A to H now, the number 0.9 is a bit smaller than number 1. The number 1.1 is a bit bigger than the number 1. The number 1.9 is a bit smaller than the number 2. The number 1.0 is the same as the number 1. This tells you that all whole numbers have got decimal point 0. E. The number 1.5 is exactly half between the number 1 and 2. This is interesting. How do we know that? Simple. 1 plus 2 is 3. And 1.5 is half of 3. The number 2.54 is bigger than the number 2.51. The number 4.61 is smaller than the number 4.63. The number 6.80 is exactly the same as the number 6.8. Now I know this is a lot to take in, so what I try to do is I try to sort of present them in a sort of graphical format. So if you look at this diagram on the screen, you'll see, first of all, on the left you'll see a table of boys and girls, and then to make it interesting, I put it in the context by sort of comparing the rate at which boys and girls lose body fat for their coming sports. So on the left you see a table there, week 1, week 2, week 3, 4, 5, 6, 7 and 8, and you see the amount they lost in grams. Now let's look at the diagram. What you see there is a representation of the table you see on the left. Weight loss over 8 weeks. And then you observe, the interesting thing I want to draw your attention to is, you'll see that apart from week 5, where you see a significant difference between 1.5 and 3, you do not see significant differences in the other comparable weights or weight losses, because they are so similar. But if you look closely, you'll see minute details. For example, 0.9 and 1, it's almost like they're the same height, but they're not. If you look closely, you'll see a little gap between the line, the horizontal line, and 0.9 compared to 1 in the graph. If you look at 1.9 and 2, you see a similar pattern of very small space between 1.9 and the marker for 2, whereas the 2 bar is touching the line, the 1.9 bar really is not. Now look at week 8. You see 6.8, 6.8. Because I use a spreadsheet to do this graph, you cannot type 6.80 and it will not show on the number. The spreadsheet is a smart software and it gets rid of the 0, but it should actually be 6.80 compared to 6.8. When you're writing decimals, you need to organize it in a way that it makes sense by recognizing the position each digit in the decimal number should be in. Now if you look at the first number, 0.9, you see the 9 is closest, the 9 on the right is closest to the decimal point, and the 0 is where it should be as a whole number. And then you see 1.19, the 0.1 is closest to the decimal point and the 9 is the next number further. What this tells you is that 0.1 is actually bigger than 0.09. So the 9 in that number, 1.19, has a smaller value than the 0.1. Okay, we'll go down a little bit. Yeah, you see 2.54 at the near the bottom there. Again, the 54 is 0.5 and 0.04. Okay, so these are all measurements of values in an effort to be as accurate as we can. Okay, what I try to do is so that you see the values. If you're adding these numbers up, you'll start from the second decimal point. That is 9 going down, 2, 4, 3, 9. You add it. You put your answer. If it's more than 9, then you carry the tens over to the one decimal place you have there. So you will add that to 91905.5.6.1 and so on. You can show your decimals on a number line as well. If you look at what I've done here, a number line is a line with numbers spaced out along it in order. The further right a number is on a number line, the bigger it is. The space in between the whole numbers can be split into divisions. If the space is split into 10 divisions, then each division is equal to 0.1. You can see this on the number line. We start from 1, 1.1, onto 1.5, 1.2, 2.5, and then 3. Each of those spaces is 0.1. So you have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then before you get to 2, starting from 1 on the left. Start from 2. In the middle, you have 2.1, 2.2, 2.3, 2.4, 2.5, which is marked, 2.6, 2.7, 2.8, 2.9, and then 3. You get my drift now. So there again, you'll see the arrow pointing to the number line, and then those little dots and strokes are just the values of the division on the number line. Decimals are used in money to show pounds and pence. Money is always written with 2 decimal digits after the decimal point, even if they're just 0 at the end. So 1 pound, you write it as £1.00. £7.38 means £7 and 38 pence. You write £5.90 not as 5.9. £5 and 9 pence is £5 and 9 pence. Decimals are also used in measuring. For example, you can use them to show meters and centimeters, cm. So 3.20 meters means 3 meters and 20 centimeters. 3.2 meters means 3 meters and 20 centimeters too. You don't need to have 2 digits after the points for measurements, okay? So you can write it as 3.20 or 3.2 meters is the same thing. 1.62 meters means 1 meter and 62 centimeters, and so on. Now let's look at how to put decimals in order. You might need to arrange a list of decimal numbers in order of size. You remember what we did for whole numbers? Now we're extending that to decimals. Example, put these heights in order of size: 0.06 meters, 2.1 meters, and 0.3 meters. From what we've just learned, you'll realize that you have to do something with them before you can do that correctly. Can you think about what? Okay, I'll explain to you. Let's go through this. Put the numbers into a column, lining up the decimal points. Make all the numbers the same length by filling in extra zeros at the end. Look at the digits before the decimal points. Arrange the numbers from largest to smallest. If any of the digits are the same, move on to the digits after the decimal points. Arrange the numbers from largest to smallest. Look at this example. Now there are 3 rows of figures, and then you have 4 steps in all. Step 1, you see 3 numbers: 0.06, 2.1, 0.3. So you need to arrange that so that all the decimals are exactly 2 decimal points. So 0.06 is correct. 2.1 is actually 2.10. Why is it important to organize them so that they are all of the same number of digits? Yes, you're right, because it is easier to compare them. As we'll see in step 3, which says, now you can start organizing. In decimals, the first decimal place is always bigger than the second decimal place. So you need to rearrange that in step 4. So 2.10, 0.30, and then 0.06. 0.06 is the smallest. Okay? Now the order is therefore 2.1 meters, 0.3 meters, and 0.06 meters. This 0.3 and 0.06 might be a little bit confusing, but if you look at it hard, you'll be able to see the difference. Just remember that the second decimal place is less than the first decimal place. So 0.06, that 06 is 6/10 of 0.1. So finding the largest and smallest decimal number. Here is an example for us to work on. Jane weighs 75.4 kilograms. Dylan weighs 52.4 kilograms and Andy weighs 75.9 kilograms. Who weighs the most? How do we compare it? Remember the example we did? Yes. Make sure you arrange them in correct decimal places. The exact number of decimal places. The whole numbers is already okay. It's the decimal places that you have to arrange properly. So, find the numbers with the highest whole number. The numbers with the highest whole numbers are 74.4 and 75.9. So that's okay. Now look at the first numbers after the decimal point. The one with the highest number is the largest. So 9 is bigger than 4. So 75.9 is the largest. Okay? Andy weighs the most. Andy weighs the most. Let's look at some practice questions. Is 11.32 smaller or bigger than 11.42? If Candice spends over £15, she gets free delivery. She spends £15 49p. Is her delivery free? Vehicles over 2.8 meters tall can't go under a railway bridge. Joe's weigh 2.84 meters. Can he drive under the bridge? Put these numbers in order, starting with the smallest. 6.2, 7.9, 8.4, 7.8. Remember your rules. Deal with whole numbers first. Put the whole numbers in order, whether it's smallest to largest or largest to smallest, depending on the question. And then you deal with the decimals. Round them all into two decimal places. And then we'll get our answer. So, Baz can lift, question 5. Baz can lift 85.6 kilograms. Carly can lift 85.9 kilograms. And Dan can lift 85.3 kilograms. Who can lift the most? Flynn has £212.56. Adi has £209.13. And Oliver has £212.59. Who has the most money? Read the question carefully, rearrange the numbers, apply the same principle we learned when we were doing comparing whole numbers, and you should be able to get your answers right. Okay, let's go on to fractions now. What is a fraction? You will understand that fractions show part of a whole, just like decimals anyway. You will know how to write fractions. You will understand that fractions show divisions. And you will learn how to recognize equivalent fractions. What do we mean by equivalent? It means they're the same. You will learn how to order fractions. When we say equivalent, if some fractions are the same, what really does that mean? It means that fractions can be written in different ways, but you need to know which are equal. So you need to be able to recognize the top number and the bottom number and compare them. So fractions showing parts of a whole. If something is divided up into equal parts, you can show it as a fraction. There are two bits of a fraction. See, 3/5 or 3/5. The bottom number shows how many parts there are in total. The top number shows how many parts you're talking about. if you have 5 children, or there are 5 of you at home, and then you bought a loaf of bread, how many parts will you share the loaf of bread into if you want them to have equal share? Yes, you'll share it into 5 parts. But let's say 2 of them are not in and only 3 of them were in. So out of those 5 parts, the 3 who are in will eat 1 part each, which is 3 parts, and you will have 2 parts remaining. So what you've done is you've divided the bread into fractions of 5 into 5 parts, and then the 3 children at home have eaten the 3 parts of the whole bread, so they've eaten 3/5 of the bread. I hope I explained that carefully. It's been a long time since I have children at home. Let's look at examples in real life. Colin has 4 pieces of cake. He eats 1 piece. What fraction did he eat? He's eaten 1 out of 4 pieces. That is 1/4 or 1/4. Betty takes 1/3 of the pens from a pack. What fraction of the pens are left? Be careful. A full pack contains 3/3. If she takes 1/3, then there must be 2/3 left. That's why I hesitate to say that a fraction is part of 1. A fraction is part of a whole. A whole can be just 1 item, or it can be a collection of items like a packet of pen, a packet of sweets, and so on and so forth. The solution to examples of fraction in real life. Colin has 4 pieces of cake. He eats 1 piece. What fraction did he eat? He eats 1 out of 4. Answer is it's 1/4 or 1/4. You say 1/4. 1/4 is correct also. Betty takes 1 of the pens of a pack of 3. What fraction of the pens are left? A full pack contains 3. If she takes 1, then there are 2 left. So the fraction that's left is 2/3. How to write fractions. Try writing the following fractions in 15 seconds, starting now. Here we go. You have half, you have 3/4, you have 4/5, you have 1/4, 1/3, you have 1/10. Note how the fractions are written. Practice questions. Becca has 2 cans of pop. He drinks 1. What fraction of the cans did Becca drink? Again, remember, she has 2 cans, but we're talking about fractions. Okay? Cliff had 10 desk calendars. He gives 3 away. How many calendars does he have left? What fraction of calendars did he give away? Here is the solution to all the questions. Becca has 2 cans of pop. She drinks 1. What fraction of the cans did she drink? You have to divide the total by 2, which you already know. And if she takes 1 out of that 2, that's 1 remaining, so it's half of the 2 she drank. Cliff had 10 desk calendars. He gives 3 away. Again, apply your knowledge of whole numbers. So 10 minus 3 is 7. So you apply those figures to the question. How many calendars does he have left? He did not give away. That would be 7/10. What fractions of calendar did he give away? That's what he gave away was 3/10. One of the most important lessons we need to learn here is that fractions show divisions. 3/4 or 3/4 is another way of writing 3 divided by 4. As you look at it, it sounds impossible, isn't it? Because you have 3 and then you have 4. Well, this is why you have fractions, because you can split 1 into a number of parts. So you can type fractions into the calculator by dividing the top by the bottom. Try it and see what happens. Don't forget to clear your calculator before you do the input. This turns them into what? Decimals. Now we will see the relationship between fractions and decimals. This is what we've done. The calculation you need to do is 3 first divided by 5 equals 0.6. Remember, you have 9 decimal points. The first 9 decimal points. When you have 10, it equals to a whole. So if you want to do this calculation, you have to take 3 and divide by 5. If you multiply 3 by 2, you'll have 6. You multiply 5 by 2, you'll have 10. So 3 over 5 is the same as 6 over 10. They are equivalent. Equivalent fractions. Again, equivalent fractions are equal in size, but the numbers at the top and the numbers at the bottom are different. Look at this example. Yeah, half or 1 over 2 is the same as 2 over 4, 2/4. The same area is shaded in each square, which shows half and 2/4 are equivalent. And common fractions. Here are 5 common fractions written as decimals. 1/2 is equal to 0.5. 1/4 is equal to 0.25. 3/4 is equal to 0.75. 1/5 is equal to 0.2. And 1/10 is equal to 0.1. Take your calculator and try to do the division. Divide 1 by 2, 1 by 4, and so on, and see whether we are right. So that means that of means times, to multiply. 1 of that. 1 of 3 means 1 divided by 3. 2 of 5 means 2 divided by 5, and so on. So sometimes you might need to calculate a fraction of something. In these cases, of means times or multiply. Okay? That is when you want to find a fraction of something. Test yourself. What is 3/4 of 200? Use your calculator. What did you get? I think you will have something like 150. Let's see whether that's right. Okay, do you see that? Remember that of means times. So 3/4 of 200 is the same as 3 divided by 4 times 200. The calculation you need to do is 3 divided by 4 times 200, which is 150. And this is how you do it on the calculator. Example 1, equivalent fractions. How do you get from one fraction to an equivalent fraction? Think about it. If you say you multiply the top and leave the bottom out, you'll be wrong. But if you say you multiply the bottom and leave the top out, you'll also be wrong. What you need to do is you multiply both by the same number. So, are 1/5 and 4/20 equivalent? Let's look at this. 1/5, remember you have to do the same to both. So 1 times 4 is 4, and then 5 times 4 is 20. So 4/20 is equivalent to 1/5, so they are equivalent fractions. Example 2 on equivalent fractions. Which of the fractions on the right is equivalent? Now this can be a little bit confusing. Again, arrange your numbers either so that the lower numbers are the same, run from highest to lowest or lowest to highest, and then you compare it with the top numbers. Now you have 6/10, but you have 1/6, you have 3/5, you have 2/3, you have 6/20. What do you think will be the answer? Let's check. Solution. Compare 1/6 multiplied by 6. What would you get? You'll get 6, and then multiply 6 by 6 is 36. So obviously, that's not the answer. Look at the second one. 3/5. Multiply 3 by 2, you'll have 6. Multiply 5 by 2, you'll have 10. So, are they equivalent? Of course, 6/10 is equivalent to 3/5. The others are wrong. Try them and see. Multiply 2 by 3, you have 6. Multiply 3 by 3, you'll get 9. Multiply 6 by 1, you have 6. Multiply 20 by 1, you'll have 20. Okay? So, your answer, 6/10, is equivalent to 3/5. And there is your solution, and that's how you do it, really. Ordering fractions. Fractions are just numbers, so they can be put in order of size like any other number. You just need to know how. If the bottom number is the same, order them by the top number. If the top numbers are all 1, then a bigger number on the bottom means that the fraction is smaller, because it means you divide the stuff into too many parts. And then from smallest to biggest, here it is on a number line as I've shown you on the board. So 1/10, 1/5, 1/4, 1/2. Which is bigger, which is smaller? The largest is half, because you just divide a loaf of bread into 2. But 1/4, it means you divide a loaf of bread into 4, you take 1. That's smaller than half. 1/5, you divide a loaf of bread into 5, you took 1. That's even smaller than 1/4. And 1/10 is even smaller. Yeah? So you need to be very careful and look at the number line and see how it's done. So you have a whole, you begin to divide it. Look at the gaps. Okay, from naught begins 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 1/10 is very small, the tiniest, and then 1/4 you divide it by 4. 1/5 you divide it by 5, half you divide it into 2 halves, and then 3/4 you divide it into 4 and you take 3 out of it, which is 75%. We'll deal with percentage when we go to level 1. Example questions on ordering. Answer to the example questions on ordering. An office is buying some computers from either Extracom computers or Ultravision computers. The computers cost the same price, but Extracom will give them half off and Extravision will give them a third off. That is 1/3. Who should they buy the computers from? Give a reason for your answer. Half is 0.5, is bigger than 1/3, which is 0.33. So they should buy from Extracom as they will be cheaper. What have we learned? We know now that decimals are less than a whole, that the decimal point separates the whole from the decimals, that the decimals are on the right of the decimal points, that fractions like decimals are less than a whole or less than 1. The different ways fractions can be written have been explained to us. And then we also have learned that the lower number of a fraction tells us the number of parts, and that the top numbers tells us the part of a fraction. We know now how to order fractions and decimals. We also know what equivalent fractions are. Okay, here are two sets of questions, practice questions. You have questions 1, 2, 3, and 4 on one set, and then you have questions 5 and 6 on the second set. So try your hand on these questions. The practice questions set 1 are straightforward questions which you have to basically compare fractions. Okay, and then 5 and 6 you have equivalent fractions, and then you have problem-like questions which you have to think a little bit more before you answer it. So you have enough to keep you going until I see you again. Thank you. I'll see you then.